So let's talk about example 4 with evaluating a calculator. It says use a calculator in radian mode to approximate the expression. Round your answer to 2 decimal places. So if you need a calculator, grab one and make sure it's in radian mode. Alright, so on A, we're just going to type in that inverse sign of negative 0.74. And what do we get?
Or negative 0.83.
Okay, good. And when we type in the inverse cosine of 1.5, what do we get there?
Undefined.
Why?
Because it goes out of the domain.
Right. So remember that for inverse cosine, its domain is between negative 1 and positive 1. That 1.5 is not in between there, therefore it's going to be undefined. What about C? If I have the inverse sine of 2.36 pi.
I got 1.13.
Okay. Anybody else get that?
Yes.
All right, good. And what about D? Tangent of the inverse tangent of negative 4.
Negative 4.
So you mean it equaled the number that was inside?
Mm-hmm.
How could that be possible?
Because they cancel out.
Because what?
They cancel out.
They do. Okay, so tangent of the inverse tangent, or if we'd had inverse tangent of tangent, they kind of like they cancel out. The only thing is you have to be careful, okay? So the inverse of any of the trig functions is on the inside. You got to make sure that that number is in its domain. So here for inverse tangent, its domain is negative infinity to infinity. And so negative 4 is between those two, correct? Now, we have to be careful though, because if it had been on the outside, if that had been inverse tangent on the outside, we have to make sure that the number that we get there is in the range of it, okay? And for inverse tangent, remember it would have had to be between negative pi over 2 and pi over 2. Now this one doesn't matter because the inverse is not on the outside. But the reason I'm saying that is because look at C. C has the inverse sign on the outside, doesn't it? So that means that my answer, the answer that I get, has to be in the range of sine, or inverse sine, excuse me. And so remember the range for inverse sine is negative pi over 2 to positive pi over 2. In which that 1.13 is between them, because pi over 2 is like 1.5 something. So it would have to be between like a negative 1.54 and a positive 1.54 when we put pi actually into the problem, okay? And so therefore we can see that 1.13 is in between those two numbers. So it's a good answer. But look at the problem itself. We said the sine, inverse sine of the sine should cancel itself, shouldn't it? And in that case, we would have got 2.36 pi, which is not what 1.13 is equal to. But is that 2.36 pi, is that in our range that we can have? Is it between negative pi over 2 and positive pi over 2? It is not. Therefore, that means we've got the right location, but our angle is too big, isn't it? So what do we do when it's too big? So if we subtract 2 pi, we end up with 0.36 pi, which is between negative pi over 2 and pi over 2. Because remember, that's same thing as negative 0.5 pi and positive 0.5 pi. And so 0.36 is between those. And 0.36 is approximately the 1.13 that your calculator gave you. All right, the reason I'm doing this, guys, is this one was all nice. It's like, hey, use your calculator, go for it. On the assignment, it says, do it by hand, no calculator. Okay, so you have to watch out for that. All right, so let's talk about that a little bit more before we move on to the next section. So I'm going to open a blank page here, if I remember how to do it on this thing. All right, so you might want to find something to write this down on. So when you're taking the composition of trig functions, I'm going to say with inverses. All right, we said if we have sine of the inverse sine of x, it'll equal x. So what we have here is either we have the main trig function of the inverse, which is our first column, or we have the inverse function of the original trig function, okay? Either way, we can think of it like as if they cancel. But you've got to remember that if the inverse is on the inside, you need to check for the domain of the inverse. Okay, and so remember that for tangent, should have spread these out a little bit more. For tangent, we need to think about, or inverse tangent, excuse me. We need to think, is that number between negative infinity and infinity? And for sine and cosine, we need to think, is that number between negative 1 and 1? Okay, because that's the domain of those inverses. It's the input. It's what's on the inside, okay? You think about its input, which is its domain.
And then for those, you have to check the range.
Now, if the inverse is on the outside, that means it's having to deal with that final answer, okay? And so therefore our answer is always our y values, which is always our range. So if the inverse is on the outside, you have to think of the range of the inverse. And so for tangent, that's negative pi over 2 to pi over 2. And I use parentheses because remember at negative pi over 2 and pi over 2, there's a horizontal asymptote, okay? At cosine, that's between 0 and pi. And between sine, if it's inverse sine, it's between negative pi over 2 and positive pi over 2. Now, of course, if it's like that one we just looked at, if it's in a decimal form, then if you're unsure, take negative pi divided by 2. Okay? It'll tell you negative 1.5 something, so you'll be able to see it as a decimal. If it's got pi in it, then you know it's negative 1/2 pi, which is negative 0.5 pi to positive 0.5 pi. Make sure that that number in front of their pi is in between the negative 0.5 and the 0.5 then, okay? So just watch out for those things. Now things to watch out for. If, like on the range here, we just saw if it was too big. For sine, we'll subtract 2 pi. For tangent, we're only going to subtract pi because tangent's period is pi, okay? And then on cosine, we can either subtract 2 pi or remember that cosine's an even function. And we're going to talk about that more in just a few minutes. Okay, so continuing on with our notes here. The next part says evaluate inverse trig functions without a calculator. So we've got the inverse cosine of the square root of 2 over 2. Now notice it says without a calculator. So this is kind of what we were doing the other day. So inverse cosine is in what quadrants? 1 and 2. Is the cosine my x or my y on my unit circle? It's the x, because remember cosine is x over r, but r is 1 on our unit circle, okay? So we are looking on our unit circle for the angle that has an x value that is the square root of 2 over 2 that's in quadrants 1 or 2. And give it to me in radians.
Pi over 4.
Do y'all agree? Yeah, it is pi over 4. Now B, the inverse tangent of negative square root of 3. Inverse tangent is in what quadrants are we going to look at?
1 and 4.
1 and 4. Okay. Inverse tangent, well, tangent is what in terms of x and y?
It's y over x.
It's the y over x. What is the y? Which trig function has y?
Sine.
Sine, okay? On our unit circle, y is our sine. All right, so we're looking for y over x. So remember, the inverse tangent we have to think a little bit about. So that means that we know this is going to be over 1. Now, if we're talking about where the inverse tangent is negative, to help ourselves out, what quadrant would we be in, 1 or 4?
4.
We're going to be in quadrant 4, okay? So remember, we're looking for an ordered pair where the x is a 1 and the y is a negative square root of 3. Right. Remember, though, because this is a fraction, a ratio, they could have both been over 2 and it would have made those 2's cancel, right? Because everything that's not a quadrantal angle on our unit circle has an over 2 on it. So we're really looking for the ordered pair 1/2 and negative square root of 3 over 2, which is what angle?
5 pi over 3.
So 5 pi over 3. What's wrong with that?
Too big.
It's too big. So what are we going to do? Go ahead and subtract the 2 pi because we know we're in the right quadrant, okay?
I thought tangent was only 1 pi.
It is, but if I do 1 pi, and I guess I should have pointed that out and I didn't think about it when I wrote it down earlier. Tangent's period is pi, but if I go back pi, I'm in quadrant 2, aren't I?
Yes, ma'am.
And so you're still going to tell me it's too big, so we're going to go back 1 more.
Yes, ma'am.
So we could do minus pi, and that would tell me 2 pi over 3, but that's still too big because that's a quadrant 2 angle. So we would subtract another pi, and we find it's equal to what?
3 pi over 3.
Negative pi over 3, which is between the negative pi over 2 and pi over 2, which is in quadrant 4.
So when we're subtracting 2 pi, what do we have to do again?
Say it again.
When we're subtracting 2 pi, it could be in between 0 and what?
For inverse tangent, you want it to end up between negative pi over 2 and positive pi over 2. You need it to be a quadrant 1 or a quadrant 4 angle. Because ours was already in quadrant 4, we just needed to go a full circle back. So that's why we jumped and subtracted the 2 pi. But if this had been a quadrant 2 angle, then I would only need to go half a circle to get into quadrant 4, okay? because tangent is positive and negative in those opposite quadrants, and that's because its period is pi. All right, and what about C without a calculator?
It would be 1.1.
Well, we said that the inverse of the original cancels itself out, and so it's equal to, excuse me, negative 1.1.
Then we have to check
But
it's in between 0 and pi.
is that between 0 and pi? It's negative, so obviously it's not, right? So we got to think of something else. Well, I don't want to just subtract 2 pi because, well, this isn't even an angle, is it? This is from the domain, which is just the numbers. I'm sorry, it's from the, well, I shouldn't say that. It is the angle, I apologize. It is the angle, but if I add or subtract 2 pi, I don't know for sure what it would do. But remember that because it's cosine, something else we can try is that cosine is an even function. Do you remember even functions? Says it doesn't matter if we plug in the positive or the negative of the number, we get the same answer at the end. So because cosine is even, that means cosine of negative 1.1 is equal to cosine of positive 1.1. And so if they're equal, then I can interchange them, can't I? So because this is even, I'm going to rewrite this to be the inverse cosine of cosine of positive 1.1. Now let's check. If those cancel, we'll get 1.1. And is that between 0 and pi? Well, pi is 3.14, isn't it? So is 1.1 between 0 and 3.14? It is, so our answer is going to be the 1.1. This one didn't fit, so we didn't use it.
So basically, you can just flip that. You don't even have to rewrite it, though, do you?
All right, so now we're going to evaluate, we're just going to find these values. And we're going to, they said to do it graphically, but I'm going to also remind you of how we did it before, just using our X, Y, and R, or you can use your opposite adjacent hypotenuse. It's up to you. That was a while back, though, that we did it, wasn't it? All right, so do you remember when we did composite functions before? You took whatever was on the inside and you plugged it into whatever was on the outside, right? So like if I said that f of x equaled x squared and g of x was equal to 2x, and if I said find f of g of x, remember f was my skeleton? And we plugged in what was on the inside, so we're going to plug in the 2x. And then we just worked it out and got our answer, didn't we? Okay, well, we're going to kind of do the same thing here. We're going to work the inside to get the answer for our outside. So when I look at this problem, the cosine of the inverse sine of negative 1/2, what's on the inside?
Sine, inverse of sine.
Yeah, the inverse of sine of negative 1/2. And so when I'm doing the inverse, what am I looking for? What kind of answer am I going to get? An angle. So I'm going to put it's equal to theta. Well, since I said that's equal to theta, then that means this whole thing here is just going to become my theta. And so I'm looking for cosine of theta. Now I'm going to come back to that in a few minutes. Let's go back and let's deal with that inverse sine of negative 1/2. All right, so if I take the inverse of that, remember that means that sine of some angle is equal to negative 1/2. Now I know that this one's on our unit circle, but we're not going to use that to find theta exactly, okay? Because look at the next one. That is not on our unit circle, 5/13. So let's go way back to when we talked about like x, y, and r. So tell me about sine in terms of x, y, and r.
Sine is y over r.
Sine is y over r. So we don't know x. We do know y. And we know r. Let's see. Now we were dealing with the inverse sine. So what quadrant were we in?
1 and 4.
1 and 4. And because it was a negative number, be more specific.
4.
Everybody okay with that? So we know that we are in quadrant 4. Tell me about x in quadrant 4, positive or negative?
Positive.
Positive. Tell me about y in quadrant 4.
Negative.
And r?
Positive.
Always positive. All right, so that means we know the negative goes with the y, don't we? So y is a negative 1, r is 2. Can I find x? How?
I believe x squared plus y squared.
Good. X squared plus y squared equals r squared. Guys, don't forget when you plug in a negative number, you need to make sure you put it in parentheses. Nothing else, put all of your numbers in parentheses. Because what I see is some of y'all, you fill it in right. You say x squared plus negative 1 squared equals 2 squared. But when you put that negative 1 in your calculator, you don't use parentheses. It tells you it's negative 1 and you go with it. Okay? You know a negative squared is going to be a positive answer, isn't it? So x squared plus 1 equals 4. So what does x squared equal to?
3.
Okay. And so when we take the square root, we get x is equal to plus or minus the square root of 3, don't we? And so what is x?
Square root of 3.
Positive square root of 3. All right, so I'm going to take a second here. I'm going to go look at that graph, okay? Because this is the way that we pretty much did it in class. But since they said to do it graphically, x is going to be like your x-axis, okay? So that means this side's going to be the square root of 3. The part of your triangle that's going to go up and down is like your y-axis. Therefore, it's going to be your negative 1. And then, of course, your slant, your hypotenuse, the radius of your circle, if we were drawing one going around here, is going to be your r, which in this case would have been a 2. And, of course, the angle that's at the center there, as a central angle, is always the one we're after. And so we're using x, y, and r to do it. And the way the triangle's kind of set up, even though you could use your x, y, and r, it's also your opposite, your adjacent, and your hypotenuse, isn't it? So whichever way you want to do it, you'll get the same answer. But the whole point is now we're after cosine of that inverse sine of negative 1/2. We said that inverse sine of negative 1/2 was our theta. So we're just after cosine of theta. We know x, y, and r of theta. We know the opposite, adjacent, hypotenuse of theta, whichever way you want to go with it. So in terms of x, y, and r, what is cosine in terms of x, y, and r?
X over r.
Okay, x over r. What is my x value?
Square root of 3.
Over what is my r value?
2.
And so that is what this is equal to. Now for the triangle part over here, we could have said, okay, cosine is the c, so it's the adjacent over the hypotenuse. Adjacent, remember, means next to, so it would have been the square root of 3. Hypotenuse is always across from that 90-degree angle, which is 2, and we'd have got the same answer that way. Okay? All right, so example 7 says to find the exact value of sine of the inverse cosine of 5 over 13. Now remember, if it's a composite function, and notice on these last two, I didn't point out on the other one, though they're not the same function, right? It's not sine and inverse sine or cosine and inverse cosine. They're different ones, so that's why we're having to do it a different way. And they don't just cancel each other out. All right, so let's take the inside and let's work on it. So the inverse cosine of 5 over 13, and we know because it's the inverse, we're looking for theta, which means all of that's theta, so in the end, I'm just going to find sine of theta. So I'm going to rewrite my inverse cosine piece here. So it means I'm looking for cosine of what angle would give me 5 over 13. Let's think about our quadrant. Inverse cosine is in what quadrants? 1 and 2. And since the number that we're using right here is a positive, is that going to be in quadrant 1 or 2?
Could be both. No, just one.
Just 1. Remember, sine is what's positive in quadrant 2, okay? So we are looking for an answer in quadrant 1. So tell me about x in quadrant 1.
X is 5.
Well, I mean positive or negative? Positive. Y is... cosine is what? Hold on. No, you're right. I'm sorry.
Positive.
Y is positive. And what about R?
Positive.
Yeah, they're all positive in quadrant 1, aren't they? All right. And then cosine, we know that cosine is what in terms of x, y, and r?
X is an 1.
All right. So our x is 5. Our r is 13. We can use our x squared plus y squared equals r squared to find y. Does anybody know what it is without solving it? It's okay. You remember the Pythagorean triples that you talked about back in geometry? It's one of them, but if you don't have it memorized, it's okay.
140 square root of 145.
Should be 12.
It's 12.
13 square, 169.
169. So if I subtract the 25 there, we get y squared is 144. And so we know y is either positive or negative 12, right? But we already said, because we're in quadrant 1, we know it's the positive 12. Now if I wanted to use the graph instead, make sure your angle is going to be in a central angle, so you want this to be in standard position. X is like your x-axis. Y goes up and down like the y-axis. And R is always hypotenuse of that slant. Okay. But either way we do it, what is sine in terms of x, y, and r?
5 over 10.
And what is my y value?
12.
12 over, what's my r value? So 12 over 13 is our answer. We don't actually have to know what theta is to solve this. We just need to find our x or y and our r. All right, so the last thing, example 8, calculating a viewing angle. It says the bottom of a 20-foot replay screen at Dodger Stadium is 45 feet above the playing field. As you move away from the wall, the angle formed by the screen at your eye changes. There is a distance from the wall at which the angle is the greatest. What is that distance? All right, so we've got this big screen on the wall, correct? And we know that it is a 20-foot screen. And it's 45 feet above the playing field. Not drawn to scale, okay? Now it says, that's on the wall. Now as we move away from this wall, it's going to be easier and easier to view that screen, isn't it? Because at the wall, we're having to look straight up and we're not really probably seeing a whole lot. All right, so there's some place out here that when we look up at that screen, that the angle is going to be the greatest, okay? It's going to be the best for us. I need to know what is that distance. Now remember, everything we've done so far has dealt with right triangles. Okay? Now, when I go to look at this screen, the screen is between that middle and that top blue line I just drew, isn't it? So the angle I'm after is that angle right there. I'm going to call it theta. But the triangle that it's in, excuse me, it's not a right triangle, is it? So therefore, I'm going to have to use the other two triangles that we can see up there to find it. Do you see the other two right triangles? We have the big triangle, right, that I drew in there at the very beginning. We've also, look at the triangle below the one that we're looking at. It's a right triangle, isn't it? So, we've got this little angle here. I'm going to call that theta 1. And then we've also got this big angle there, so I'll call that theta 2. How could I find theta if I'm able to find those other two angles? What's the relationship between those other two angles with theta?
Should be opposite of, right?
Should be what?
It should be like, oh, what am I trying to say?
Well, if I know the big angle and I know one of the small angles, how can I find the other small angle?
It's
We can't say it's half.
not half, but the other side, the other part of that angle.
We can subtract the 2, okay? So we could take what we labeled up there as theta 2, subtract out theta 1, and that's going to give us the angle that we're looking for, isn't it? All right, so that's what we're going to do. So we got to figure out those other two angles. So tell me about theta 2. Well, let me see. I'm going to change. I'm not going to put an equal sign. Because I'm not going to put what it's equal to yet. All right, so theta 2, the big angle. Well, let's see. What do we know about this angle? Well, we know over here its total is what?
65.
So the side across from it is 65. So we can either say that goes up and down. So that's like which axis? The y-axis. So that could be our y value. Okay. We're looking for this side over here, which is our, goes left and right, so that's our x. So which trig function could help me find theta 2 if I know y and I know x? Tangent. So we know that tangent of theta 2 will equal the y, which is 65, over the x, which is x. And so if I'm looking for theta 2, I need these two to switch places. What am I going to use to make those switch? What is that called when I'm switching the input and the output? The inverse. So theta 2 is equal to the inverse tangent of 65 over x. Now, we can't go any further because we don't know what x is yet. But hold on, okay? Let's talk about theta 1. Theta 1 is that smaller triangle there at the bottom. Well, I know across from it is how much?
45.
45, and it shares that same bottom, which is x. So the 45 goes up and down. It's like my y. The x goes left and right like my x. So again, we can use tangent, can't we? So it means that tangent of theta 1 will equal 45 over x. So theta 1 is equal to the inverse tangent of 45 over x. Well, we don't know what x is, which is our whole issue, right? But it told me I want to find the distance from the wall at which the angle is the greatest. How would I find something if it's the greatest? Okay, but I don't know either one yet. So, that's a good thought. Greatest. Where did we talk about greatest before? When we did some graphing. What would I look for if I'm looking for the greatest when I'm graphing? Highest point. What is that also called? The maximum. So, let's look at what we've got here. So we said that our theta was equal to theta 2 minus theta 1, right? Okay, so we know theta is equal to, well, we know theta 2 is the inverse tangent of 65 over x minus theta 1, we said was the inverse tangent of 45 over x. And so we can put that in our calculator now and we can graph it, can't we?
And we just look for the maximum. Right?
Well, just put it in your y equals right now and wait on me. Okay, so we can just hit graph and hope for the best, right? But let's think about this, guys. Let's think about our window. So let's go to our window and let's set it some for us. So let's change our x min, our x max, our y min, and our y max. Now x was that distance, right? We don't really know how far we need to be from the screen, but is it going to be a negative distance? No, I don't think so. And so we're just going to have to kind of randomly pick a distance. Now, our distance is in feet. We're probably not going to be like just 10 or 20 feet from it, correct? Because just think about it. It's way up on the wall. So if you're standing up there at my wall and you're having to look way up, it's going to be really uncomfortable if you have to have your neck way up, isn't it? So we're probably going to be a little bit out there. So give me some number we're going to try for our x max. What's that?
3.
So you think we might just be 3 feet away?
200 feet.
200 feet? Okay. I think 3 is going to be way too small because I'm going to be looking way up if I'm only 3 feet away from the wall. So I would definitely go bigger. So the 200, we'll try it. All right. Now my y, we put this in y equals, right? But our equation was theta equals. So our y is our theta. What kind of angle do we think we're going to have? Well, it can't be a negative angle, can it? And I'm going to be looking up. So at what point do you think it's going to become really uncomfortable to hold your head up for very long if you're looking at a screen?
Probably like 15, 20 feet.
Probably more than 15 or 20 degrees. So let's just say halfway up. So let's just say 45 degrees. Now think about this though. What number would I not go past?
60?
Well, I definitely wouldn't go past 90 degrees because in that case I better just turn my butt around, shouldn't I? Okay? So I wouldn't worry about going more than 90 for sure. But if you think about it, if you raise your head more than 45 degrees, your neck's going to start hurting after a while. So they make it where these screens aren't going to have that huge of an incline on your neck, that big of an angle. So we do expect this to be a small angle. Like you said, 15 to 20 degrees is probably going to start being uncomfortable. So it's probably going to be smaller than that. All right, so now that we've got that, change your window and go look at your graph and see if you can see the maximum.
I see.
You don't see anything? Oh, one other thing, guys. Make sure you're in degree mode on this one. I'm sorry. That's the one thing I forgot to tell you. Make sure you're in degree mode because I want you to make sure this makes sense. So the problem is set up to be where it'll work in degrees. Now do you see something?
Yeah.
All right. Do you see a maximum?
Mm-hmm.
Can you find that maximum? Good, do it. Remember, go to that second trace, choose maximum, go to your left bound, your right bound. So when I graphed this, I saw something like this. Now, I may have gone out further. I probably did because I put, I think, 500 as my X max, but whichever. Okay, but you should see something like that. Okay, yeah, I did not go up as tall either. So yeah, yours is fine. Yours is squished down a little bit more because I also didn't go up to 45. All right, but either way, find that maximum value that you can see. And what did you find it to be?
10.4.
Well, give me the ordered pair. So 54.1 approximately, and then 10.48. Is that what you said?
No, I got 48.
I didn't. Anybody else get about what I did? Yeah? Okay. So now remember, another reason I like doing that window was I didn't label it, but we had said the X, remember, was the distance from the screen. And Y, we said, was our angle. So the question is, what is the distance that's going to give me that greatest angle? Well, the distance is what? My X or my Y? It's the X. So the distance is, what, that 54.1? So the distance of 54.1 feet will give us the greatest angle. Now, I didn't ask for it, but what is that greatest angle? Well, my angle, looking over where I did my window stuff, my angle was my Y's, wasn't it? So that greatest angle is that 10.48 degrees.